Okay, let's review ahead of the midterm some of the things that we've discussed so far about quadratic equations. In Unit 2, we saw a lot about how to graph and write them, and we learned about the three different forms. We found vertex form, which is right here. It's that a times x minus h squared plus k. We also found intercept form and standard form. With each of these, we got some practice in how to write it given a graph and how to graph it given a function. And we talked a lot about what these variables here, written in color, mean. When we look at A in each of these, when we look at A controls how much the quadratic shrinks or stretches. That's talking about how wide or super narrow a quadratic is. It talks also about how it curves. So if A is positive, we typically see it open upward. If A is negative, we see it open downward. We talked about H and K in vertex form being the vertex. So our vertex is just H as the X value and K as the Y value. When we're looking at a particular quadratic equation, the vertex is that point right there, boom, where it stops decreasing and starts increasing, or stops increasing and starts decreasing. We also talked about how H is also our axis of symmetry. And that is this dashed line that we can draw right down through the vertex. And what we notice is that the quadratic is actually mirrored along that axis. So any point that we have over here is directly mirrored over here. And that H helps us find the axis of symmetry. So vertex form was really great because it gave us right away, we had our vertex, we had our axis of symmetry, and we could start plugging in some points. We could plug in an x value. We could plug in some x value here and figure out what the output would be or what the y value would be. But what it didn't do is it didn't help us find some of these other important pieces of information. So we also had intercept form, the A here, also controlling shrink, stretch, and curve. But here we have P and Q. What P and Q are our x-intercepts. This is where the quadratic crosses or intercepts the x-axis. Remember, the x-axis, of course, is the horizontal one, and y is the vertical one. So if we had a quadratic that looked kind of like this, these 2 points right here where it crosses would be our x-intercepts. When we had intercept form, we actually had a kind of clever way, as well as a formulaic way to find the axis of symmetry. The clever way was, well, hey, we know that it's going to be directly between those 2 points. So we could actually reason that out if we had numbers that were friendly, or we had a formula where we said, well, hey, the axis of symmetry, H, is just going to be P plus Q divided by 2. All we're really doing there is finding the total distance between P and Q and then cutting it in half. So finding that midpoint between the two. But again, here, we could probably figure out the vertex. We know the x value because we have h, so we could actually just plug in h here into the x and try to solve for y. But one thing we don't have a good way of there is finding that y-intercept. So we don't have a way to find the y-intercept there. And in vertex form, we didn't have a good way to find the x-intercepts or the y-intercepts. There are some kind of algebraic ways around it that we could think of, but No quick way, no quick way. And then in standard form, we have a couple of additional values, particularly C is of interest. C is our y-intercept. Y-intercept. So again, when we see a quadratic, boom, this is our y-intercept. That's where it crosses the y-axis. Now, we had a somewhat helpful thing here with B. B didn't actually stand for anything, but B helped us find H. If we had H equals negative B over 2A, and we kind of walked through the derivation of this, but it's not something that you need to know. Just know that this works, and we tested it out in class, and we verified that. So we can take negative B divided by 2 over A, and we would actually get that vertex point as well as our axis of symmetry, and we could figure that out. But once again, notice here that we don't have a good way to get the x-intercepts. So essentially in Unit 2, we played around with these, got really familiar with these 3 different forms, but we also left the unit recognizing that none of them are perfect. Some of them actually have pretty difficult pathways in front of us to find all of the information that we need. And that's where Unit 3 comes in. So let's look at an example right away. I'm just going to go kind of quickly through what we know. Let's say we have an intercept form quadratic. Let's take a look at y equals x plus 2 and x minus 4. Right away, we know some stuff. We know that a is 1 because there is kind of an unspoken one right there. We know that p is negative 2 and q is positive 4. Those are our x-intercepts. So we can see right away that intercept form is super helpful. What we don't have just by looking at it are h and k, which is our vertex, and we don't have c, which is our y-intercept. So previously we were able to visualize this. We were able to put our x-intercepts right here at negative 2 and 4. And we knew based on the property of that axis of symmetry that kind of right between those, if you didn't see it right away, you could calculate it. We see the axis of symmetry pop up right there. We know that that is our h. So we actually know that h is at positive 1. K is just this function evaluated with x equals to 1 because we know we're looking for that particular x value. We just solved for that in h. So we would be able to plug in 1 for 1 plus 2 and 1 for 1 minus 4. 1 plus 2 is 3. 1 minus 4 is negative 3. And we know that k is negative 9. Negative 9. So there's our vertex. We can throw the vertex, boom, right there. And already we have a pretty good visual on this. We're able to kind of see that it would curve up, and we see our x-intercepts, we see our vertex. But what we do not have is our y-intercept. We don't have that yet. But of course, we can find it. Now, we looked at this before. We said, well, okay, well, the y-intercept is going to cross the y-axis. And any place that a point crosses that y-axis, x is going to equal 0. So before we were able to kind of take this and plug in 0 for x and figure out what our y-intercept would be. So let's just kind of look at that real quick. If we plugged in 0 for x, we would get positive 2 times negative 4, and we would find that it's negative 8. So we actually find that it is right there. And that kind of makes sense based on the idea that that's curving up and going through there. There is another way. We can multiply the binomials. Binomials we talked about in class just means two numbers, or two terms, bi being two, nomials meaning terms. And because we have two terms in each of these up here, we call those binomials. Figure this out. Y equals x plus 2 times x minus 4. And we used a thing called FOIL, which just stood for first, outer, inner, and last. Well, what does that mean? It means we're going to multiply our two first terms together, our two outer terms together, our two inner terms together, and our two last terms together. So we actually get y equals x times x is x squared, x times negative 4 is negative 4x, 2 times x is 2x, and 2 times negative 4 is negative 8. Of course, this is the part where we might look and see if we could combine any like terms, and we can. So we have x squared minus 4 plus 2 is going to be minus 2x minus 8. What's interesting here is notice that we just took intercept form and we converted it to standard form pretty quickly, just by multiplying those binomials. And here we can actually verify, well, hey, there's that C term. We knew C was going to be in this spot in standard and actually verified what we got. So multiplying the binomials is a good way to convert intercept form to standard form. Now, of course, when we're doing this, we do want to be mindful of one possibility that might pop up if we saw an intercept form that had an a value other than 1. So something that might look like this. Now, notice we would do the same exact thing, except now we've got this other number out here. Some people might be tempted to start distributing that right away, but I would say FOIL first and then distribute that A in. So here we would do FOIL, so we get y equals 2 times, and then x times x squared, we would have plus 2x plus 1x minus 2, combining our like terms. We would get plus 3x there in the middle. And then we can distribute that 2 in there. So we would actually get this as 2x squared plus 6x minus 4. That would be our standard form. So just be mindful that if that is out there, that is what you do. Now, of course, it would be nice to take vertex form. And do the same thing. Vertex form and do the same. So an example of a vertex form quadratic might look like y equals negative 2 x plus 1 squared plus 8. And again, we can start to quickly reason through this one. We know that a is negative 2, so we should expect this one to curve down. We see that h is negative 1, k is 8, and so immediately we are able to then take that and put it on the graph at negative 1, 8. Now, with this vertex form, we are perhaps the furthest away from being able to figure out everything that we need. It gives us the vertex nicely, but it does not give us the y-intercept. It doesn't give us C right away. And it also doesn't give us the x-intercepts right away. So we got to do some work for those. Let's think about this one. Before we were able to kind of reason through a little bit, and we said, well, the y-intercept is wherever x equals 0. And so we can plug that in over here and just see what happens. X equals 0. So let's see, y equals negative 2 times 0 plus 1 squared plus 8 So let's see, 0 plus 1 is 1. Not too bad so far. 1 squared is just 1. Still not bad. Negative 2 times 1 is negative 2 plus 8. And then that comes out to positive 6. So we're able to throw that on the graph there. And that lines up with what we're expecting because we're thinking this is going to curve down. Now, the harder one before, we did talk about this a little bit, is just thinking about, well, hey, wherever the x-intercepts are, y is going to equal to 0. And so we can do that. We can set this y equal to 0. Let's see if we can figure that out. So we have 0 equals negative 2 x plus 1 squared plus 8. And from there, we're just kind of using our Algebra 1 skills to manipulate. So we know we got minus 8 equals minus 2x plus 1 squared. That's getting rid of our addition first. Then we're going to get rid of the negative 2 by dividing both sides by negative 2. So over here, negative 8 divided by negative 2 is 4. We have x plus 1 squared. How we undo an exponent is by squaring both sides, or square rooting both sides. We have the square root of 4. So equal to x plus 1. And then we would subtract 1 from both sides. So we'd actually find out that x is the square root of 4 minus 1. And the square root of 4 is either positive 2 or negative 2. So we would find that x equals 2 minus 1, or x equals negative 2 minus 1. So we'd find 1, and we would find negative 3, and those would be our intercepts. So we'd have it at 1 and negative 3. And at this point, we can go back and draw in a quadratic that looks something like this. Something like that. And we can use multiplying binomials to convert this as well if we have our vertex form. We want to convert it. Well, let's think about this for a second. We got negative 2, then we have x plus 1 squared. What does squared mean? Squared means something times itself. So we're going to have x plus 1 times x plus 1. We'll have a little plus 8 out here. Now, this is starting to look a little bit familiar. We've got two groups, so we can FOIL that. We're going to keep the negative 2 and the plus 8 just kind of to themselves out here. Let's see what we get. We get x squared plus 1x plus 1x plus 1, which is going to be x squared plus 2x plus 1 plus 8. We have negative 2x squared minus 4x minus 2 plus 8. Then we would have minus 2x squared minus 4x plus 6. And so notice what we've done here is we've taken vertex and just converted it to standard. And we actually see that our answer was right. We have C right where we expect it to be at 6, and in that slot in the standard form equation. So far, this is largely review of Unit 2. The only thing that we've really introduced is this idea that we can convert from vertex and intercept form to standard form by multiplying our binomials. And in fact, if you look at these two examples we've done out, I don't think that necessarily that process or the plugging in zero process is easier or harder than each other. It just gives us two ways to do it. However, multiplying our binomials does reveal some interesting patterns, particularly when we want to go from standard form to intercept form. This is perhaps the trickiest one we've run into so far. Our standard form is y equals ax squared plus bx plus c, where we get the c right away, and we can get h and k there, but getting our x-intercepts is difficult, very difficult. And in intercept form, well, hey, it's actually just right there for you, just to be plucked right out. Boom, boom, those are our x-intercepts. And so we're acknowledging, first and foremost, that, hey, it would be really cool if we had a way to just kind of quickly convert from standard to intercept form, that we could be really exact with our answers, we'd get our x-intercepts, and we would be happy. With that, I think this is a good time to pause this video, because that will transition us into the latest topic of factoring and finding zeros. So I'm going to pause this video. This is a nice recap of essentially most of what we talked about in Unit 2 and starting into Unit 3, and then I'll post another video after this with the second part of this midterm review going over how to factor and find our zeros.